Hey guys, welcome to week number 2 of distance learning. Last week, I was really impressed with the amount of students that were logging on and not just like doing a little work, but like really doing a lot of good thinking work and like thinking a lot about that math. And so I want you guys to continue that. Remember, like you are going to have to take on a little bit more responsibility than normal, which means that if you're confused, I'm not going to know until you ask for help in different ways. The best way is to request a meeting on Zoom with me. Okay, and you can find a link there in our resource page or in the weekly overview that is sent out to parents and students. Um, Other ways you can contact me with my phone number, or you can contact me um, over email. Okay, today we're starting week number 2. And this week is about equivalent expressions. Okay, so equivalent expressions means like a math expression is like a math sentence, and equivalent means like valued the same. So like $1. What's going on with my pen? Okay, $1 would be is equivalent to 4/4. They aren't the same. Like if I was to hand someone $1 and was to hand someone 4/4, they wouldn't look the same. They don't weigh the same amount. They're not made of the same material, but they are equivalent because they can buy you the same amount of stuff at the store. So they have an equivalent value. That is what we're looking for with our math equations as we move forward. And to start representing this, I'm going to start with doing some with numbers. And these we've actually kind of had this discussion before. That it was that last question on the test. And so I'm going to look at one with numbers, and then we're going to move on to where this becomes a little bit more complicated when we start introducing variables. Okay, so the first one with numbers looks something like this. So if I have so I'm drawing this out. Okay, so here, and as a reminder, I'm expecting you to be following along, so you should have a note page that looks a lot like mine. Okay, so as a reminder, or sorry, I just said that. This here, you could write, someone might look at this and I'm like, okay, how many squares are there? And I'm not asking how many purple squares there are, how many white squares there are. I'm asking how many squares there are in total. Okay? And we could think of this number as a set of 4 squares added to a set of 6 squares. And that would look something like 4 plus 6. This is our expression number 1. Okay? But if I drew the same thing out, and again, I'm going to color these in. Okay. Someone might also do the math this way. where they have found that there are two groups of the same kind of pattern. And they might draw this as 2 white squares plus 3 purple squares, and then multiply that by 2. This is expression number 2. Okay, so because we worked from the same exact picture, one with, did I freeze this? Yeah, that like froze perfect timing. Because we worked from the same picture, we know visually that these two are equivalent. They represent the same amount of squares. But we could actually prove this, or so like let's do a little check. And we're gonna go and do our basic. So I'm gonna look at this 4 plus 6. And I'm wondering, is that equivalent to? Is that equal 2 plus 3 times 2? That's a question mark right there. And so I can go downwards. I'm going to do my addition problem here. So that gives me 4 plus 6 gives me 10. And this side's a little bit more complicated because remember I have to do my parentheses first. Okay, so that goes down first. So this is 5. And then I have to keep that times 2. Okay, and then at this point 10 kind of just stays 10. And now we have a multiplication problem because we're thinking PEMDAS. We're going back to the stuff that we did last week. And this equals 10. So here we have 10 equals 10. And so yes, they are equivalent. Okay, so we've proven it in 2 ways. 1, we saw this picture up here, and 2, we've done the math to check whether expression 1 and expression 2 are equivalent. Okay, this is pretty straightforward when it comes with numbers. I'm not saying it's easy. I'm just saying like the process works a little bit more simply, and you often will get to a really nice simple single number equal to a other single number. And if they're not the same number, we know we did something wrong or they weren't equivalent to begin with. This gets a little bit more complicated when we add in variables. And so to this week, we're kind of working on connecting those 2 ideas. Okay, so I'm actually going to switch to another paper right now because I want us to have enough space. So if you have a second piece of paper, just flip yours over to take some notes. Okay. Okay. So here, and this is going to take a little bit. Oh, I wish I had these drawn out already, but I'll just talk. So we're really thinking about growth right now. Because variables come into play not when we have a single static or still situation, but when something is changing and we have to figure out what the pattern of change is. And so we can no longer just look at a single set of squares. We have to look at a set of squares that is growing. And so I'm going to look at figure number 1. Or let's start with, we never start at 1. We always start at 0. So we're looking at figure number 0, and I'm going to say that figure number 0 looks like this. And I'm going to highlight these ones. I'm going to color them in. Why I do that will come apparent in a little bit, but I find it helpful. So now figure number, I'm just letting you know I'm making these up. Like I literally made these up. They're like sketched out on the board next to me, which is why I keep looking off to my right side. I will give you these. You don't have to come up with tile patterns. You have to explain tile patterns. So figure number 1 is going to look something like this. Okay. Figure number 2 is going to look like this. And hopefully you're already starting to see a pattern. Figure number 3 looks something like this. Okay, you see that it's growing. You see it's not growing randomly. You see it's growing by a consistent something. Now our job is to kind of explain in many different ways how this is growing and how can we talk about this growing with pictures and with math and with other ways. So the first way that I like to think about it growing is I like to think about what figure X would look like. And X represents the figure number. Okay. And I'm just going to draw this one for you guys. Notice here that I've kept this number 3 from figure 0 each time. I kept that same one highlighted purple. So again, we're going to keep that one highlighted purple. Okay. And now what I notice is that I seem to have these groups that are like, this is one long, and now it's 2 long, 2 long, 2 long, and now it's 3 long, 3 long, 3 long. It's always as long as the figure number is. So I'm going to make a block that is X long. And so this one we have to use our imagination. If it's figure 100, that block is hella long. That block would reach all the way across my page. But if it's figure number 4, that block is only 4 squares long. We're now making a representation that should represent every single figure. So there's 1, 2, 3. Okay. And so now the challenge is, how do I represent this in different equations? So one way you could do it is you could think of this as 1, 2, 3. And then this is 1, 2, 3 x's. So this could be like plus x times 3. So that's one way I could write this out as a math problem. My computer did something weird. Okay. Another way, so that would be like grouping it kind of like here, here, and here. Okay? Another way I could see this being written out is 3 plus x, so that's 1x, plus x, that's another x, that one, plus x. Okay? So we have a second way of writing it out. I can even come up with a third way of writing it out. Okay, I want to do the grouping this way. So this would be like x plus 1. And then I know that that happens 3 times. So this is times 3. These are 3 different ways of representing this same tile pattern. We can even check those. Let's see if they work. And we know how to check them because if they're equivalent, I should be able to plug the same number in for all of them and come out with the same number. So let's do a check. So we're going to go with, this one's our 3 plus x times 3. I'm going to put, this one's 3 plus x plus x plus x. And this one's x plus 1. And my phone froze. I'm getting better at catching that. Times 3. And let's try this for x equals 5. Okay, so let's do this first one. So first we start with our plug-in. And then we do PEMDAS. Oh my God, you see how it all comes together? Okay, so plug in. So this is 3 plus, we're plugging in 5 for x times 3. Okay, we don't have parentheses. We don't have exponents. We do with this multiplication problem. Okay, we don't have division, but we do have addition. 3 plus 15 is 18. Okay, let's see if it works for the rest of them. Okay, so if I plug in, this is 3 plus 5 plus 5 plus 5. And this is all addition. So 3 plus 5 is 8 plus 5. Oh my God, I'm going to type this into a calculator. Where'd my calculator go? 3 plus 5 plus 5 plus 5 equals 18. And I could do that all in one row because it was all addition. Otherwise, I'd have to have split it up. Okay? Okay. Lastly, we have our third one, which was, so we start with plugging in again. Okay, and now we have our P, which is parentheses. So we do that one first, so 5 plus 1. We do what's inside our parentheses. So this is 6 times 3. 6 times 3, I know 6 times 2 is 12. So 12 plus 6 is 18. And so we don't have exponents. We do have multiplication. 18. Okay, so if you notice, they all gave me the same number. To really be sure, you should check it with more than one number. Like, I should see if it works with x equals 15. I should see if it works with x equals 12. I should see if it works with x equals 200. If you're a real mathematician, or you are a real mathematician, but if this was like proving for like writing a paper or stuff, you would have to prove it for many, many steps. But right now, I'll just have you prove it with one number. Okay? So, this is kind of our process right now. We started, let's review what we covered. We started about how we could think about the same set of squares in two different ways, and we could write two different math problems that got us to the same answer. Even though they looked really different, they were equivalent because they came up with the same value. We then saw what this looked like when we started looking at things that grew and changed. So we looked at this one tile pattern that's growing. We turned it into a figure X tile pattern. And then we wrote 3 different equations that could represent that figure X. And then, just to double check, just to make sure that these all truly were equivalent, we plugged some numbers in and we got the same answer each time. And I did a final proof that these are equivalent. Okay, you guys have some homework. Make sure that you are doing this homework in a notebook, you're taking a picture of it, and you're uploading it onto Google Classroom. Then, if you have any questions or you just want to say hi, check into my Zoom sessions. I'm here. We can even do a couple of the problems together. So, you guys are awesome. Stay happy, stay healthy, and welcome to your second week of online learning. Thank you so much. Have a great day.